Alright, so the molecule I'm going to use for this example is SF4, sulfur tetrafluoride. And for the sake of completeness, we're going to do the Lewis structure, the VSEPR geometry, and then the hybridization scheme for it. So the first thing you need to do to get the right Lewis structure is to get the right number of valence electrons. The sulfur kicks in 6. Each of the 4 fluorines contributes 7 valence electrons. So that gives us a total of 34 valence electrons. Alright, so let's put them together. The formula tells you that sulfur is going to be a central atom, and the 4 fluorines are going to be outer or peripheral atoms. So the first part of the procedure I recommend is to put single bonds with everything to at least get the skeletal structure for the molecule. After that, start putting 3 unshared electron pairs around each of the outer atoms, in this case the fluorines. So there's already 8 of the 34 electrons showing, so let's put the rest of them on there. So this is 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. We have 2 more, and so the procedure says if that's the case, put the remaining electrons on the central atom, so 33 and 34. So this is the preliminary Lewis structure, and it's actually a pretty good one. The fluorines are all octet satisfied. The sulfur has an overfilled octet, but that's okay because it is a second row element, and we can do that because with this particular structure there's no formal charge on the sulfur or any of the fluorines, so it's worth overfilling the octet on sulfur, that group 3 element. So this is actually the Lewis structure for SF4. So the important thing to learn from here on in is the number of electron domains, and in this case there are 5 of them, which basically gives you the answer for everything else. So let's give it a quick draw here. So if you actually want to do this right, so the electronic geometry for this molecule is going to be the word we use for that is Trigonal Bi-Pyramidal. The molecular geometry, the one that's just the atoms, for this particular combination, the phrase we give to that is seesaw. So let's draw that with some perspective to see what it actually looks like. So you've got the sulfur in the middle, you have the 2 axial positions and one of the equatorial positions in the plane of the screen, the other of the equatorial positions coming out towards you, and the other one going back into the screen. Remember, the equatorial positions were the more spacious ones, so the unshared electron pairs go there, and everything else gets a fluorine. So that's the structure. And now, just remember what the phrases were, or what the schemes were. You've got 5 electron domains around there, so you need 5 hybrid orbitals to accommodate them, and that is simply sp3d hybridization. So SF4 is an electronic tetrahedral bipyramidal molecular seesaw geometry molecule that has sp3d hybridization, and that's how you determine hybridization schemes.